Now, looking at this example, so you have 4 rivets, horizontal, distance between rivets 200. Name this as A, B, C, and D. Label it as A, B, C, and D. So this is the applied loads on the bracket. So you have your primary shear load PS, PS, and PS based on the applied load P. Okay, based on the applied load P. Okay, so each of these share the same amount. So you take P divided by 4. So that means it's 0.25 P for each. 0.25 P for each. And then the eccentricity is somewhere around here. So P times E will give you an anti-clockwise or counterclockwise turning. Counterclockwise turning, that's why your FA, FB is acting up, FC and FD is acting downwards. And why they are vertical? Because remember, secondary shear load has to be perpendicular 90 degrees to or perpendicular to the radial length, okay, of its own radial length. That means LA, LB, LC, and LD. Okay. So once you have known all that, once you have drawn this diagram, okay, then now apply the formula that I have said just now. Apply the formula that I have said just now with all your LA to LD and your P times E, you will be able to find out your FA. So once you find out your FA, use the proportionality between the secondary shear load and the radial length. You develop each of these equations here, which I've explained earlier. So you will be able to find out FB, FC, and FD. All will give you something in terms of P. Everything here will be given as in terms of P. Then you find your resultant. Now, your resultant should be in this form. So resultant A, let's say you look at resultant A. Now, FA acting up, PS is acting down. So let's say PS is 0.25 P. FA is 0.15 P. So PS is greater than this. So you take PS minus FA. So you get a resultant A. Because it's up, the other one is down. The same for this also. FB is acting up. PS is acting down. Okay, so when you put your PS and FB, you will be able to get RB as 0.2 P. Then when you refer to C, this force and this force, primary and secondary shear load, they're both acting downwards in the same direction. So you add them up. Add it up, so you got 0.3 P. RD, so when you look at this, both of them is acting down. So the resultant will be acting down. So you need to take, okay, you add up these two components here to get 0.4 P. So from RA to RD, you pick up the maximum, that is 0.4 P here. Okay, 0.4 P as RD. Then from there, since we know the diameter, so now we can find out the P. That is 78.55 kilonewton. Okay, thank you very much. That's for this example.